Skeleton is composed primarily of cartilage. As the skeleton grows, this cartilage is gradually converted to bone in a process called ossification. These events can be seen most clearly in the growth of a long bone. Ossification of a long bone begins about the second to third month of fetal life, with formation of a primary ossification center at the center of the diaphysis. Here, osteoblasts, bone-building cells, begin to convert embryonic cartilage to bone by incorporating calcium salts into its matrix. As the bone's shaft grows in length, it also grows in width, and the marrow cavity is formed. Osteoclasts, cells that break down bone tissue, are important in this remodeling process. At about the time of birth, secondary ossification centers appear at each end of the bone. Here, osteoblasts and osteoclasts will mold the epiphyses into their final form. A zone of actively growing cartilage, the epiphyseal plate, persists in a region called the metaphysis, located between the diaphysis and the epiphysis at each end of the bone. Bone tissue forms on both sides of each epiphyseal plate until growth is complete and the bones are completely ossified during the late teens to early 20s. However, cartilage remains over the ends of the bones as protective articular cartilage. Zooming in on the epiphyseal plate, one can see the area where cartilage continues to proliferate. On either side of this area, the new cartilage is gradually converted to bone by osteoblasts. This process occurs much more rapidly on the diaphyseal side of the growth region, adding length to the shaft. When skeletal growth is complete, the epiphyseal plates themselves become ossified and are visible only as faint lines, the epiphyseal lines across the ends of the bones. Bone tissue does continue to grow and repair itself throughout life, however, as wear and tear destroys it or injury requires repair.